Let's go ahead and take a look at the quiz that you just took, okay? I'm going to post not only this video of the quiz, but I will also post pictures of the quiz as well. So that way you can go back and look at the answers as well as not only on picture, but on the video, whichever one you prefer. Let's take a glance here. We do have a test coming up on Friday, so we need to make sure that hopefully you watch the videos. It's for your own good, I think. Maybe not. It says a rock here has a mass of M. It's thrown horizontally off of a building from a height of H. As shown above, which is down here, the equations, the speed of the rock as it leaves the thrower's hand at the edge of the building is V sub 0. How much time does it take for the rock to travel from the edge of the building to the ground? Okay, well, again, my suggestion is to go ahead and draw a picture of it. I'm going to have a building, going to have the ground, and I have a person on this building, and they have a rock in their hand. And they are going to throw this rock off the building. Okay? They told me that the height is H. So from here to here, the height is H. They told me about the mass. Do I care about the mass? At this point, we haven't even utilized mass in any equation. So the mass was just extra stuff to throw you off. It also told me that the speed of the rock as it leaves the thrower's hand at the edge of the building has a V sub 0. Okay? So the VI I know is 0. That's already a given to me, but they just said it anyways. How much time does it take for the rock to hit down to the bottom? The question mark is T. Okay. Well, they told me about the VI and the vertical Y component. They talked to me and they told me about the H in the vertical distance Y component again. Did they say anything about the X component? No, they didn't. Everything they said was about the Y component. Well, I know when it comes to time is one of those one of those variables that transcends between the X and the Y component. So whether I have the X or the Y information, I can find the T. Remember, I see this as a parabola, so I'm going to think the X and Y component, right? I can write and list my variables, okay? D, V, T. The D, the VI, the T, the A, the VF, okay? Now, if I go back and again, look, this right here is a vertical. This right here is the vertical. I know that the velocity vertically before it's thrown is going to be 0. Okay? So the information that they gave me was the vertical Y component. What is that equation from our notes? That's the vertical Y component. Isn't it D equals 1/2 AT squared? Right? And if I want to solve for T, okay, let's solve for T. What am I going to do when it comes to that? Can I write this in another way? I can. Let me show you another way I can write this. D equals 1/2 times, instead of A, can't I use G for gravity? G times T squared. And look how I wrote the 1/2. Okay? So both of those are the same thing. I need to solve and get T by itself. Now, if you were looking at this side algebraically, what would you do? I would have to get 2 out of the bottom of this division, and I need to go ahead and get rid of that first. So I'm going to go ahead and I'm going to multiply this side by 2. That cancels. Multiply this side by 2. What's next? Well, I'm going to divide this side by G to cancel. Divide this side by G. But don't forget, t is still squared. What's the next step after that? What if we square root that t and square root all of this? Let me rewrite this. Two d over g square rooted equals t. Isn't that the same thing as this? The square root of 2h distance. They use the h instead of the d. Over g instead of a. Correct answer is E. It was the same exact equation that we used for the y component. Instead, they just used the h for the height regarding distance, and they used g for the acceleration of gravity instead of a. Okay? So it's the same exact equation. It's what we algebraically do here, but they did it in another way. Same exact thing. Next one. It says here that the velocity of a projectile is launched as a horizontal component of VH and a vertical component of V sub V. The air resistance is neglected when the projectile is at the highest point of the trajectory, okay, at that location. Which of the following show the vertical and the horizontal components for its velocity? So when it comes here, what is going to be the vertical velocity? Isn't it going to equal 0? Why? We call that non-zero acceleration, right? Those two vectors finally got to the point where they cancel each other out. The velocity is 0 vertically. What about horizontally, though? What is the velocity there? Isn't the horizontal velocity constant all the way throughout the parabola? So wouldn't it be whatever it originally was, the horizontal component of V sub h? Wouldn't it be the same exact? It would be V sub h here, V sub h here, V sub h here. And it wants to know, what about its acceleration? Would acceleration be the acceleration of gravity, which is negative 9.81? So my correct answer would be E. All right, E would be my correct answer. I've got a tent that's supported by a rope that's tied 8 meters away from the tent. As shown. If the tent is 3.5 meters high, how long is this a rope right here attached to the stake? I don't know about you, but I see this as a squared plus b squared equals c squared. Not only that, but here's my right angle. So that means that this leg is my hypotenuse. So that's my c squared. So in this case, it would be 8 squared plus 3.5 squared equals c squared. All right, not a problem. So 3.5 is 12.5. Right? 64 equals 76.5. Is that my answer? No, it's not. I need to square root it. My answer comes out to 8.75 meters. Next page. It says here though that I've got a ball that's sitting on a table. Then a student pushes it off the table with a speed of 2 meters per second. That is 1 meter above the floor. How far along the floor is it going to land from the table? Please make sure you use the correct SI units. All right, let's do our drawing. How tall above the ground is it? It told me that it was 1 meter above the ground from here to here. It told me that the speed of this ball was 2 meters per second. Right? It's going to form a parabola shape. Question is, what is that distance right there? First thing I do is do my x and my y component. X is d, v, t. Y is D, V, T, A, V, F. VF is really never given to us. A we know is negative 9.81. T was not given to me. My VI initially in the vertical component is 0. The D is 1 meter. The distance on the X component is what I'm looking for. The velocity they told me was 2 meters per second, and the T was never given to me. We need to be able to do our drawing and at least do the X and Y components here in the T chart. I'm telling you, it's really going to help you out. Then I get my highlighter and I decide, well, what side am I looking for? I'm looking for the X component side. I now should be able to know that the X component side has an equation of D equals V times T. Can I solve for it? No, I cannot. I'm missing 2 variables. So I have to go to my Y side, solve here, find my T, get my T and plug it in over here. So it's a 2-step problem. D equals 1/2 AT squared, or D, which is 1 meter, equals 0.5 multiplied by 9.81 times T squared. Divide by 4.905. That cancels. Divide by 4.905. All right. So 1 divided by 4.905 comes out to 0.2039. Again, though, that's T squared. That's not going to cut it, so I don't square root that. The square root of 0.2039 comes out to 0.452 seconds. That is not my answer. I'm going to go ahead and write that over here. 0.452, 0.452. Now I can go ahead and I can solve for the distance, which is really going to be my answer here. D equals V times T, or D equals 2 times 0.452. So 2 times 0.452. The distance that it lands away from the table is 0.904 meters. This is my answer. Let's go to the next question. The next question here says that an astronaut stands at the end of a lunar crater. The key word here was lunar, wait a minute, astronaut and lunar crater, and throws a half-eaten Twinkie horizontally with a velocity of 5 meters per second. The floor of the lunar crater is 100 meters below the astronaut. What is the horizontal distance that the Twinkie is going to travel before hitting the ground? Okay, so first thing here, what are we working with? We're not working here on Earth. Remember, I told you there was a couple of assumptions that we can make here in physics. Okay? Other than that, we don't assume things. But one thing that we can assume is that we're always going to be on planet Earth unless they tell me something different. And when they told me astronaut and lunar crater, this is not Earth. We're on the moon. So no longer can I use 9.81 as gravity. I hope you did not use that number. Okay? Remember in our notes, though, it says, and look, I so happen to have my notes right here, that the moon is 6 times smaller than Earth's gravity. Why? Because the moon is 6 times smaller. That's the reason why the gravity is 6 times smaller. So if I got step 1, 9.81 divided by 6, I'm going to find the moon's gravitational pull. So 9.81 divided by 6 comes out to 1.635 meters per second square. That is step 1 before I do anything. Now I'm going to go ahead and I'm going to go do my drawing like I always do. So here's my moon. There's a lunar crater. There's an astronaut here in his big old spacesuit. And he's got a half-eaten Twinkie. He's going to launch it. Now, when he tossed it over there, it had a horizontal velocity of 5 meters per second. The lunar floor, the floor of the crater, is 100 meters below the astronaut. From here to here is 100 meters. What is the horizontal distance? So from here to here. Okay, so here's my drawing. What do I do? Step 1. After I do my drawing, that's step 1. Step 2 is my X and Y component. D, T, V, D, T, V, I, A, V, F. Question mark. Not given to me. 5. 100. Not given to me. 0. It is not negative 9.81. It is truly 1.635. And yes, it will be a negative because it is pulling down and not given to me. Get my highlighter. What side am I looking for? I'm looking for the X component side. Do I have enough information to solve for it? No, I do not. I've got to come over here first, find the T, plug the T over here, and then I can do this. So it is a two-step problem. So let's go ahead and do that from step number 1. D equals 1/2 AT squared. Now our A is not going to be gravity on Earth. 100 equals 0.5 times 1.635 times T squared. Divide by, well, this number I don't have memorized. 1.635 times 0.5, 0.8175. Cancel. 0.8175. So 100 divided by 0.8175 is 122.32 T squared. I've got to square root it. 122.32 comes out to 11.06 seconds. Let's come over here and let's fill that in. 11.06, 11.06. Now I have enough information so I can solve for this. So part 2, D equals V times T, or D equals 5 times 11.06. The distance comes out to about 55.29 meters. Or if you run it to 55.3 meters, that works as well. There we go. So all of these problems so far you are completely capable to answer on your own. I promise you, we have done problems like this already. I know you can do it. Which of the following statement is true about projectiles? A projectile is a free-falling object. A projectile experiences negligible or no air resistance. A projectile must be moving in the downward direction. A projectile must be accelerating in the downward direction. A projectile does not have to have horizontal velocity, motion, which is true. A projectile could begin its projectile motion with the downward velocity. Yeah, because you just dropped it. All the above. All the above. Okay. Let's keep going. A pelican is flying 30 meters per second with a fish in its mouth. It drops the fish, which ends up traveling 40 meters horizontally. How high is this pelican above the water? You must add SI units. Well, let's do our drawing. There's my pelican. He's got a fish. The fish falls like this. Okay. The pelican is flying horizontally this direction at 30 meters per second. The fish ends up traveling a distance of 40 meters horizontally. Question here is, how high up is the pelican? There's my drawing. That's step one. What's step two? X and Y component. DTV, DT, VI, A, and VF. 9.81, 0, not given, not given. The distance here is 40, the T not given, the velocity is 30, the distance is unknown. What side am I looking for? I'm looking for the Y component side. Okay. Do I have enough information? I don't have enough information. So I'm going to have to come over here, solve for the T, plug it in, and then I can solve for this. D equals V times T, or 40 equals 30 times T, divide by 30, cancel, divide by 30, right? T equals 1.33. That's part one. Let's do part two. D equals 1/2 AT squared. I'm going to say 1.33, 1.33. Now let's plug this in. The distance equals 0.5 times 9.81 times 1.33 squared. Don't forget to square that. 1.33 times 1.33 times 9.81 times 0.5 equals 8.68 meters above the ground. Okay? And let's keep going. Says here, which of the following statements is true about the horizontal motion of projectiles? A projectile does not have a horizontal velocity. A projectile with the rightward component of motion will have a rightward component of acceleration. A horizontal velocity of a projectile changes by 9.81 meters per second. A projectile with horizontal component of motion will have a constant horizontal velocity, which is, so far, that's true. The horizontal velocity of a projectile is 0 meters per second at the peak. Nope. That is my only true statement. There we go. Let's keep going. A projectile was shot out of the ground with initial horizontal velocity of 5 meters per second and initial vertical velocity of 3 meters per second. What is the angle that the projectile was fired? All right, so here's the ground. The horizontal is 5. The vertical is 3. It's going to shoot it like this. We're looking for the theta here. That's my unknown. What do I see? I see this part right here creates a right triangle. So if I go to the opposite side, that's my hypotenuse, my adjacent, and my opposite leg. I need to think of SOHCAHTOA. I'm going to highlight what I have. I have the adjacent and the opposite leg, the A and O. The A and the O looks like it's going to be my tan. So the tan of the theta equals the opposite over the adjacent. Or the tan of the theta equals 3/5. Well, let's do that. 3 divided by 5. So the tan of the theta equals 0.6. That is not my answer. Remember how we said like square and square root? You have to do the opposite. When you're looking for the theta, you have to do the inverse, which is the opposite of the theta. So now I have to hit the second key up here at the top. Tan 0.6, close parentheses. Please make sure you are in degrees and not radians. So the theta is 30.96 degrees. Let's keep going. It says here, from a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole is 18 degrees. Calculate the height of the flagpole. All right, let's go ahead and do that. Oops. Here's the ground. It says here, from a horizontal distance of 80 meters, so from here to here is 80 meters. Got a flagpole. The angle of elevation from here to here is going to be 18 degrees. The theta is 18 degrees. How tall is the flagpole? So let's go ahead and get my highlighter. I have this leg, and this leg is my unknown. Well, what do I do next? We find the right angle. We draw the arrow to the opposite side and call this my hypotenuse. The theta and right angle form the adjacent leg, and my last is my opposite leg. I have the A and the O. I need to write down SOHCAHTOA. Who is A and O? The tan. So the tan of the theta equals the opposite over the adjacent, or the tan of 18 degrees equals the opposite over 80. Now we're going to use our algebra. Multiply by 80, cancel. Multiply by 80. Let's go ahead and find the tan of 18 degrees. Multiply that by 80. The height of the flagpole is 25.99 meters. Some of you rounded to 26 meters. That's perfectly good too. Let's keep going. We've seen this picture before. Look at the picture below. If the VI at location A was 16 meters per second, what is the acceleration at location A? This is the velocity here. What is the acceleration? Well, the acceleration in the location is going to be negative 9.81 meters per second square, right? Hopefully we all agree with that. Let's keep going. Couple more problems. We've got a picture here. There's a projectile going. It says here's a free-falling trajectory of an object thrown horizontally from the top of a building as shown with the dashes over here. Okay, so it's moving this direction, right? Which one of these best corresponds with the direction of the horizontal velocity and acceleration for this object at location P? At location P, does it have acceleration? Yes, it does. What direction? Down. Does it have a horizontal velocity? Yes, it does. What direction? This way, to the right. Well, let's see. This is velocity and that's acceleration. Velocity has to be, okay, now we're down to here and here. And acceleration is down. It can only be B. B is my only correct answer. Let's keep looking. Here's a skateboarder who's gets a rolling start along a sidewalk and jumps down meters to a lower level below and rolls on. The time the skater is in the air between the rolling off of the upper level to the down level is increase if the skater goes faster, decreases if the skater gets a longer distance, unchanged if the skater gets a faster rolling start, decreases if the skater. It does not matter how fast he's moving horizontally. That does nothing. He's going to be in the air for the same amount of time. Why? Because he's from the same distance, the same height. If he was going to go to a different height, then the time would be different. But it's going to be unchanged. No matter what. No matter how fast he skates this way, when he jumps off, it does not make a difference at all. The path or shape, and this is straight out of your notes, a sentence straight out of it, from a projectile curve is called a parabola. And a vector is an arrow that describes magnitude and direction. There is all of the quiz answers. I will put this video on for you. Share the link as well as take pictures. Thank you.